Today I wanted to talk a bit about the Spryker Monitoring Integration, the new feature or the product that has been developed recently by Spryker and currently being adopted. So let's take a look. Yeah, what it is. By the way, maybe has somebody heard about this already? Already the first time? No, no one. Okay, then let's move on. First of all, intro myself, Volodymyr Lunov, team lead product management. You can scan my contacts here if you would like to, and I'm happy to present this new product to you. So what it is, right? While talking to our enterprise customers, we realized that they often have their own monitoring solutions already in-house, which are very different, right? And some time ago, we decided that we would like to offer an integration which will allow to observe Spryker and connect Spryker observation to the platform of choice of a customer. So for example, it's possible to send information from Spryker platform into Dynatrace, Datadog, or New Relic, or others that you own. Important that they should be compatible with open telemetry, open standard, right? So it integrates, right? So you receive your data in one place, and you can act on this data, you can process this data, and set up your own dashboards, monitoring others, whatever you want. Yeah. This solution is forwarding application traces, so requests and the breakdown of the request to your system, as well as health check metrics of the backend services of Spryker. So you will receive like a traffic light of the main database, healthiness of Redis, Elasticsearch, RabbitMQ, and others. And probably the most valuable is that the customers who have their own monitoring solution already, they unify the monitoring, right? So if they have their own team driving the monitoring, they can have everything in one place. And with a New Relic solution, so with another option that we offer, it's usually simpler to start, but it creates a silos, right? Because New Relic is then running with us, with Spryker, and your teams might be monitoring other applications separately. Yeah. What is OpenTelemetry? Yeah. OpenTelemetry is an open standard and framework which defines APIs, it defines data format, libraries, how to collect information, how to send it, and it tries to standardize different ways of collecting information so that it can be sent in a unified way in any system, right? And with this, by using OpenTelemetry, we have built a vendor agnostic monitoring experience that allows you to connect to your system. How does it work? Yeah, high level overview. Yeah, so here you see like Spryker, right? And we have two components here. We have our cloud PaaS platform where all the backend services like database, Redis, RabbitMQ, Jenkins, maybe containers, something like this, right? For those, we collect health indicators like a traffic light, which is forwarded through OpenTelemetry layer to your monitoring solution. Then for PHP, for the applications, our teams, actually Edward is driving this team and leading this team, so if you have any technical questions, maybe we can answer it even now or as a follow-up later. Just reach to us, please. So PHP instrumentation, it instruments Spryker project. It enables distributed tracing, which allow to connect different services all together. Yeah, the traces are split into spans, and then the custom attributes and code errors are also attached, and again forwarded through this layer to the monitoring system. This is like a bottom top view, right? But if we go next, yeah. If you have other applications, yes, so you might have a front-end application, you might have a mobile application like an iOS app or Android app, you might have other services, yeah. And right now with this new feature, you could ship Spryker, the monitoring information of Spryker into the same monitoring solution, right? So it means that your, let's say, Datadog will be able to connect your front-end application, mobile application, Spryker, other services all together. So you receive like a new views and new possibilities to take a look at all the applications you monitor. It's especially important when you have a big landscape of different apps. Yeah, the solution might be less important if you have only one solution, right? So if you have only Spryker Web Shop, then probably this might be too much for you. But if you have third-party applications that you also observe, and you have a dedicated team, they will be probably very happy about this. Yeah. So in one place in your monitoring system, you can connect, right? So then Datadog will be able to connect the front-end application to Spryker, or other way around, or mobile application to Spryker. You will be able to see end-to-end traces. Your team will be able to do cross-app troubleshooting. Yeah, meaning that usually you know that when a problem happens, it might actually appear not in the app where the problem is. Yeah, so let's say the mobile application crashes, right? But it crashes because Spryker crashes. Yeah, and in general, it's very hard to find this kind of errors. And there are two dimensions here. There is organizational dimensions, because usually those buckets are owned by other teams, but also technical one, right? So unless you have everything in one place, technical, you will never see these correlations. Yeah, and through the integration, it allows you to see it in your system. And of course, you have holistic error dashboards, right? So you see all the errors from all the applications. Usually, those systems like New Relic, Datadog, Dynatrace, they can correlate errors from different apps, and they can help you a lot, because then they will show you, okay, look, the error happened in the mobile application at, I don't know, 16.10, right? It's right now time, but it happened in the front-end application 5 seconds before. Yeah, maybe there's a correlation. Do you have any questions on the high level about how it works? No? Okay. Because then, like, I would then switch the sharing, and if I could, how do I do it? And actually show some technical details. Yeah.
I see a lot of code lines.
Yes. That's the right view. Yeah. So, and I will try to make it bigger. Is it readable?
Yes, looks good to me. I see people nodding, so
yeah.
Yes.
So here you can see Grafana. Grafana is like open source solution to access monitoring and observability data. And here we see our internal view. Yeah, because I would wish to run this demo in other solutions, but I just don't know Dynatrace and Datadog well enough, and therefore I think this one will be good enough. But you can imagine that how it will look in your solution. What I did, I just filtered requests by our demo environment, and I said that, okay, I would like to see the requests which are longer than 1 second, just to be there. And you can see that it shows a lot of things, right? So there were some requests to cart items posts, cart items again. So actually this is an artificial test. Yeah. And when I open any of them, you can see on the right side, it loads a breakdown and also an example of distributed tracing. So you can see here that everything starts with Glue API, with a post request, then this request actually delegates it to that. There are 2 calls to that. You can see them here. So one is post to persistent gateway sync storage quote. Another one is add to cart sync. Yeah. So this is an example. So different colors are different services, and this is so-called distributed tracing, where one application is connected to other applications. When you have the front-end app and you use your managed solution like Datadog, you will also see the front-end app as an entry point here. Yeah. Then for each application, as you see, we break down the execution flow by main code points. Also, we show you select all the database queries with full query name and or short one, yeah, where your teams can troubleshoot. And this breakdown kind of shows what exactly is happening. So you can see that this API call, which landed with Glue, actually most of the time was spent in that by adding to cart and doing some things, right? And like this action took a lot of time adding to cart and this one. So pretty good and very visible. And then in addition to this, we can take a look at errors, right? So if I filter by errors, yeah, let's open something. Yeah. So here you see that the error has happened. But that's a good example where you see that the error entry point was again Glue API, but technically the error actually was somewhere below. Yeah, so Glue API called that, and then error happened actually low below here. Yeah, at the end, like the engineers can find that there was a problem. I don't know. There is a stack trace details about what exactly was wrong, so developers can understand. And only by correlating and propagating errors, so you can see that the error was happening here, but actually the error propagated to the very top. Yeah, it's possible to understand why this service failed, and why it failed because it was a low-level error somewhere below. Yeah. In addition to this, we of course we capture. Let me just open my notes. In addition, of course, we capture all the external requests, right? So if I filter by Redis, right, I will reset errors, and I will reset duration just to make it clear. Yeah, so it finds what was wrong. The base system name is Redis. Okay, for some reason didn't find anything. Let's try Elasticsearch. Okay, I know why, because I said error, yeah, like this. Yeah, so Elasticsearch, I just need to reset the error, yeah. So with trace, we add requests to all the services. So you will see a query to Elasticsearch, you would see a query to Redis, and again, your developers can find what exactly the query was, how long did it take, and where it went to. Let me switch back to Redis, because now I think it will filter something. Redis. Yeah. So yeah, here in a small example, right, that there is a key being read, like this key was read, and it took 52 milliseconds to read it. Same is applied to RabbitMQ. Also, we trace and add console jobs, so everything which is happening asynchronously. Yeah, and that's the small intro that I wanted to share. Of course, like not everything is traced in detail because it has an overhead. By default, we ship that like the GET requests are traced with 10% probability, and the post requests are traced with 50% probability. But you can configure it. Just keep in mind that more details you add, it adds overhead, right? Because adding like additional information or meta information to each request, of course, consumes memory and some CPU time.